All right, you guys, let's get these last two questions. Here we go. The figure above shows the graph of f prime, the derivative of the function. I'm going to pay attention to the fact that it's negative 7 to 7. I can see my points right there, so that's good. F prime has horizontal tangent lines at negative 3, 2, and 5. They usually just tell you that so you're not like guessing. Oh, I think it's around there, but I'm not sure. They just like confirm it for you. And there's a vertical tangent line at 3. How weird. And then go ahead and put a vertical tangent line there so that I remember. Okay, great. Find all the values for relative min, relative max. Oh, this is such easy money. How many times have we done this now? Okay. Let's see. F prime of x, making a sine line graph from negative 7 to 7. And I'm looking where the derivative actually equals 0. Okay, and this one is about checking the values of it. So between negative 7 and negative 5, it's positive y values. Between negative 5 and negative 1, it's negative y values. From negative 1 to 5, it's positive y values. And it stays positive. Wait. Yep, and it stays positive from 5 to 7. So it's a positive all through there. Okay, cool. Increasing, decreasing, increasing, increasing some more. Okay? So I can write up my two parts. F of x has a relative max at x equals negative 5 because f prime of x changes from positive to negative. Okay, and then part B, same exact thing, just wants to know about a relative min. Oh, I flipped those. Whoops, relative min comes first. Okay, fine. Oop. Okay, that's part B. Okay, part A, relative min. F of x has a relative min at x equals negative 1 because f prime of x changes from negative to positive at x equals negative 1. All right? Nice. Okay. Find all x values for negative 7 to 7 at which the second derivative is less than 0. Well, guys, second derivative less than 0 means negative. And second derivative negative means concave down. So I'm kind of just figuring out where it's concave down. It's just worded a little bit differently. All right, so anyway, we're going to do our sine line graph of our second derivative. Negative 7 to 7. Okay, and the second derivative is where we have horizontal tangents, or derivatives where the slope is 0. And it told us it was at negative 3, 2, and 5. And so we think about our guy hitting the slopes on here, right? Anyways, he's got negative slopes down to negative 3, and then he's going positive up to 2, negative down to 5, positive up to 7. So the second derivative is negative on the open interval negative 7 to negative 3 and 2 to 5. Okay? Okay, now we do have to say one thing about this really quickly, guys. It's a little tricky, so we'll get used to weird things like this pop up. I'll just try to tell you. There's a vertical tangent line at x equals negative 3. Okay, which we drew up here. It means like it's not actually well, what we should have done is we should have put at x equals 3. Is we actually should have put a point on our graph here at 3. You might ask, well, what difference does that make? Well, the only difference it makes right here, you guys, is that they're still both negative, but instead of writing it 2 to 5, I'm going to write it 2 to 3 and 3 to 5. Because we can't include that 3 in there, unfortunately, because it's not negative at that point, it's undefined. Okay, that's something that's a little bit tricky that we just need to kind of talk about if it ever comes up on, you know, practices or anything like that. Okay, and then cool, absolute max. We have not done that yet, so we are actually done. We can skip letter D on number 7. Okay, so now let's head over to number 8. This seems perfect because it's have all the things that I'm looking for a test question. All right, so here's a graph of a derivative. Let me just read through this real quick here. A function has a domain on the closed interval -1 to 4, so there's like endpoints there. Arrange the closed interval -1 to 2. I feel like we did this one in class. That's okay though. It's still a great idea to go over it. That's important later. That's important for later. And then it also gives me these points, which I think are also important later. Let f have the derivative that is continuous and has the graph shown above, relative maximum. Okay. And then it asks about absolute minimum. I'm going to go ahead and change that word to relative minimum. Okay. I forgot to basically take off the absolute problems on here, which, you know, we need to learn that still. All right. Make a sign line graph of f prime, going from -1 to 4. We know that it equals 0 at 0 and 2. And when I'm testing values into that, it's positive because it's up here. It's positive because it's up here. And then it's negative. Okay? So I'm going increasing, increasing, decreasing. So I would say f of x has a relative maximum at x equals 2 because f prime of x changes from positive to negative. All right? Okay, so I'm being like very deliberate with the way I'm saying these. You need to do this on your test. I mean, if you have the whole thing right, but you don't put the prime right there on the f prime or something, that's going to count your explanation wrong, you know? All right? Where does it have a relative min? We don't know absolute, so we'll do relative min. Actually, f of x does, not have a relative min because f prime of x does not change from negative to positive. All right? And that's my justify. Okay, A, B. Now I'm going to do part C. I'm like all over the place with my work, you guys, but it's because I want to continue looking at the graph while I'm doing it and I want to scroll so much. So try to like not be all over the place with your work when you guys are doing these. All right, find the interval which f is concave downward. So I'm looking at f double prime. I'm looking at it from -1 to 4. And it's like there's a vertical tangent here at 0. There's a vertical tangent here at 1. And then there's another one at 3. All right, and when I'm testing this, these are downward slopes. These are upward slopes, downward slopes, upward slopes. Okay, so I have concave down, concave up. So letter C is asking me, find the intervals where it's concave down. So I'm going to say f of x is concave down on the interval -1 to 0 and 1 to 3. All right, that's where it's concave down. Give all the values for which it has points of inflection. Part D. F of x has a point of inflection at x equals 0, 1, and 3. Neither of those say justify, so you don't have to justify. Okay? If it says justify your answer or give a reason for your answer, you need to be able to give a reason for it. All right, and now on the axis provided, sketch the graph. Okay, sketch the graph. Here we go. Okay, you guys, when I'm sketching a graph, it's going to give me points. That's cool. It did give me points, right? -1, -1. 0, 0, 4, 1. Okay, awesome. It gave me those points. Now I'm going to look at the increasing. It increases from -1 to 0. It increases until 2, and then it decreases. Now we're not going to go above 2, partly because, I mean, the graph goes there, but also that's kind of what this range is talking about. F, the function, is closed from -1 to 1 and -1 to 2. So just don't go higher than that, right? Okay, and then now we're going to go ahead and draw in the concavity. Well, it's concave down here, and then it's up to 1. So I'm just going to put a point like that to here. And then it's down 1 to 3. So through there and to there, it's down all the way to 3. And then it's up 3 to 4. All right? If you guys went through and watched all these videos, you do fabulous on your test. You guys are awesome. Great job getting through it.